All right, we have three forms of linear equations. We talked about them in the last video. We have slope-intercept form, which is our form that we use for graphing, primarily for graphing, which is it has y by itself, and it gives us the slope and the y-intercept. We have our point-slope form, which is really kind of a transitional form that we use to find an equation in slope-intercept or standard when we have the slope at any point. And then we have standard form, which is, well, there are certain types of equations, and we will do more of this later in the semester, but it's not really for graphing, and it's got some rules around it. A, B, and C have to be integers, A has to be positive, and C, the constant, is always by itself. So when we try to convert between these forms, we have questions. I looked at last year's STAR test. There were 5 questions. I mean, the one that was released, okay, I'm not doing anything wrong. I looked at the released STAR test. There were 5 questions that had to do with going between these different formats, slope, intercept, standard, point, slope, answering questions about graphs, about slope, about y-intercept, features of these graphing features when there was standard form involved. You can't answer questions really about standard form. You really can't answer those questions when they're in standard form. It's very tricky and unnecessarily difficult. So we're going to talk about how to convert between these different forms. There are reasons why you would need to. So for example, let's say you had a graph, and you could write an equation to the graph, but all the answer choices were in standard form. Well, you could convert all 4 answer choices into slope-intercept form, or you could just convert the one you wrote into standard form and find the one that matches it. Let's say they give you a point in the slope and say, we need this equation in standard form. Well, shoot, then you just write it in point slope, move it to slope-intercept, and then turn that into standard. I'm going to show you how to do that today. It's actually not very hard. And I could give you guys a set of pretty simple instructions, but I want y'all to know how to do it. I don't want y'all to have to rely on tricks, but maybe we'll get there. Okay, so first of all, when I talk about going into standard form, we talked about standard form. We have C by itself. So my goal is to get this by itself on one side of the equal sign. Okay? The part that seems to really confuse you guys is you don't know whether you're supposed to add, subtract, or multiply, divide. Okay? So I want you to think about what's happening right now. I have negative 1/2 x minus 7. Those two things are separated by a subtraction operator. That means I have to add or subtract to separate these two terms. Okay? So if I want to leave the negative 7 behind, I've got to get rid of the 1/2 x. So it's positive 1/2 x because it doesn't have a sign next to it. So in order to get rid of it, I'm going to subtract 1/2 x. And remember, whatever I do to one side, I got to do to the other. Okay? That's going to zero this out and leave me with negative 1/2 x plus y equals negative 7. Now, technically, right now, I have ax plus by equals c. Okay? I've got my c isolated. But I have these rules. A, b, and c must be integers, and a is not an integer. Okay? It's a fraction. A has to be positive, and a is not positive. So I have to figure out what I'm going to multiply this row by to make a positive, to make a whole number. Well, 1/2 times 2 is going to make a whole number. If I multiply by negative 2, then I'm going to have a positive whole number, which is what I want. Okay, so that's what I'm going to do. Remember, if I multiply the left side by a number, I have to multiply the right side by that same number. So negative 2 times 1/2 becomes positive 1x. Negative 2 times y becomes negative 2y. Negative 2 times negative 7 becomes positive 14. Now, this is a perfectly fine answer, but remember, in math, we don't usually write it that way. So it would be x minus 2y equals 14. And even though you don't see the integer there, remember, we have that invisible 1 that is right there. Okay? So there's our answer. All right? Now, if we want to go from standard to slope-intercept, so let's say we have a table. Let's say they give us this equation and say which graph represents it, and I have 4 graphs. Well, they're all in slope-intercept form. So instead of me converting all 4 of them into standard form, I convert this into slope-intercept form and see which one is which is the correct graph. So in this case, again, my goal is with slope-intercept form, I want y by itself. Okay? So I need to get this negative 3y term by itself. So again, I'm thinking I have 2x minus 3y. They're separated by a subtraction operator, so I have to add or subtract to get rid of them. Well, I want to leave the negative 3y behind, so I'm going to subtract 2x, because 2x is positive now. Okay, that zeroes these out, and I have negative 3y equals negative 2x plus 9. Okay, now again, my slope-intercept form has y by itself, not negative 3y. So I'm going to divide by negative 3 to get rid of it. Why am I dividing? Because negative 3, if they're touching, negative 3y or y over negative 3, that means that I multiplied or divided them. I have to multiply or divide to undo it. In this case, since it's negative 3 times y, I divide to get rid of it. So I have y equals negative divided by negative makes positive 2/3 x. 9 divided by negative 3 is minus 3. And there is my equation. So again, I could then look at the 4 graphs they gave me and see which one has an equation of 2/3 x minus 3. Okay, now the last one, if they give me like, well, in this case I gave you an equation, but if they gave me, if they said the line has a slope of 2/3, and which of the following equations has a slope of 2/3 and goes through negative 3, negative 4? Well, and they give me all standard form equations. Well, I can start with point slope, and actually I think there was a question almost exactly like that on the EOC, on the Algebra 1 end of course exam last year, the released one. There was one almost exactly like it. So we're going to start with it. We'll start by putting it in point slope form, and then we're going to start distributing, and we're going to actually get it into slope intercept form. Okay, so we have y plus 4 equals 2/3 x plus 2. Okay, I'm going to subtract 4 from both sides, and I get y equals 2/3 x minus 2. What did I do wrong here? Oh, okay, it's just a different equation. Okay, all right, so now I've got my equation in slope-intercept form now, but I want standard form. So I'm going to keep going and convert slope-intercept into standard form. So again, in standard form, I want my constant by itself, so I need the minus 2 isolated. That means I've got to subtract 2/3 x. That zeroes out. I have negative 2/3 x plus y equals negative 2. And then I've got to get rid of this fraction, so I'm going to multiply both sides by 3. And I need it to be positive, so I'm going to multiply both sides by negative 3. Okay? So I have 3 times, that's going to be 2x. Negative 3 times y is, whoopsie, let me erase that. What happened there? Minus 3y. Negative 2 times 3 is positive 6. And now I'm in I'm in standard form, and I can see which one matches.